Hello, this is Britt Caswell with another example video from the SavvasRealize textbook. This is lesson 1-1, example number 5. So in this example, we are looking at what is called the average rate of change over an interval. When we're looking at this, I want you guys just to think about the slope. Okay, so remember, a rate of change is just the slope. So what we're doing with this is we are taking the slope over various intervals, if I were to connect them with a straight line, and then I'm comparing them to each other. Okay, so I want us to start by creating a general formula that's going to help us determine the average rate of change. And this is actually something you guys have seen before in Algebra 1. I think in 8th grade they also cover the rate of change. So it's something you've seen before, it's just called something else. Okay, so we're using just the slope formula. So let's talk about how we're deriving the formula we're using for down below. So we have some function, okay? In this case, they have an exponential function. It could be anything. It could be a straight line, it could be a parabola, it could be a cubic function. It doesn't really matter, okay? And what we're doing is we're picking two x values. Okay, we're going to pick the x value a. Okay, here's my dotted line for the x value of a. And then we're going to pick the x value b. Okay, I'm not specifically saying what those numbers are because I can pick whatever number I want for them. Now, if I were to plug a into the function, I would get some y value, right? That's how we generate the graph. But what we do is we would call that f of a. Okay, that's just the y value that comes in there. So the ordered pair at this point is at a comma f of a. Now if I were to plug in b into the function, I would get another y value. And the ordered pair for that point on the function would be b f of b. So now I have two ordered pairs, and in order to find the average slope of the line between those 2 points, is I'm going to pretend that there is a completely straight line between them. We're also going to pretend that I know how to draw a completely straight line. And what we're going to do is we're going to find the slope of that hopefully straight line. So remember from middle school, the slope of a line is just the rise over the run, right? Or another way to say it, you take y2 minus y1, you subtract your two y values, and then you subtract your two x values. You guys remember that? So the slope of this blue line, I'm going to take my y value here, f of b, and subtract my y value here, f of a. And it looks ugly and confusing because you guys aren't using numbers yet. You're just using letters. But this gets a lot easier. So then we divide it by, remember to make sure that your ordered pair matches here. So then I'm going to do b minus a. If you flip them, like if you do a minus b here, but b minus a there, then your slope comes out backwards. So the average rate of change here would be f of b minus f of a over b minus a. So let's talk about what these rates of changes do over the intervals. Okay. So for this blue graph, first we want to look at the slope of the line between -2 and 0. Okay. So for the interval -2, 0, I would take my slope, so I'd take the y value here at -2 and here at 0, and I would subtract them. They have the same y value here, right? So 1 minus 1. And then I would take my interval. So I usually start with the second one first. So I'm going to say here my y value was 1 and my x value is 0. And then I'm going to subtract. Here my y value was 1, my x value was -2. So 1 minus 1 at the top is 0 over 0 minus -2 is a positive 2. So my slope over that section is 0, which you guys could have told just from looking at it, right? So now let's check the interval 0, 3. So at 3, my y value is 1. I'm going to put a matching 3 down there to remember that I paired 1 with 3. And then here, at 0, my y value is 1. So I'm going to put a 1 where the y is, a 0 where the x is. This turns into 0 over 3, which is 0. So these have the same slope. And then I'm going to check the interval that covers both of those intervals. This is a big deal here. Okay, so I'm checking the two intervals together now. I'm going to check from -2 to 3. Oops, that should have been a square bracket. Notice the square brackets here mean that they're including the 3 and the -2, like that. So, here, my y value is 1 and my x value is 3, so I'm going to put a 1 up top, 3 down below. Over here, my y value is 1 and my x value is -2. 1 minus 1 is 0. 3 minus -2 is 5. So my slope here is 0. So the biggest thing that we're looking for here is for these matching values. So because our slopes across all these intervals was the same slope, this is telling us that the function is linear. Okay? So this one is a linear function. And that's just what we're confirming right there, because sometimes we'll have a graph and we won't necessarily tell if it's linear or not. So now let's look at this orange one, and we're going to do this orange one fairly briefly, just by inspection. So if I were to look at the slope from -2 to 0, just visually, I see that it rises by 1 and runs by 2. If I visually inspect the slope from 0 to 3, I also see it has a slope where it rises by 1 and runs by 2. So from 0 to 3, my slope is also 1/2. Now if I look at it from -2 to 3, if I were to plug into the slope formula, I would see here where my slope is still rise 1, run 2. So my slope is still 1/2. And as you see from the graph, yes, it is linear. So this is also a linear function. So let's check out this green one, which is clearly not a linear function, and let's see how it changes here. So if I calculate my slope for the interval -2 to 0, I'm just going to do it with visual inspection on the graph. You can use the formula as well. So this line, essentially, it is falling by 4, running by 2. Alright, so that is a slope of 4/2, which is 2. If I check out my slope from 0 to 3, so from here to here, I see that it's falling by 9 and running by 3. Oh, I'm sorry, that's a -2 on that one, because it fell by 4. So here, it's rising by 9, running by 3. So that slope here is 3. Now if I look at the interval from -2 to 3, okay, so I'm checking out this kind of dotted line up here, I see that I'm rising by 5, and I'm also running by 5. So my slope here is 1. So by seeing that I have all of these different slopes, I can see that it is not linear. It's a nonlinear function. Another thing worth noting is, do you see how the slopes here happen to match that one? It's kind of interesting, isn't it? So now number 5, we're going to go through this fairly quickly. So what I would do here is I would actually just real quick plug in the value of the function at our 3 values. So if I plug in the value of the function at -2, I would get the absolute value of -2 plus 2. An absolute value, remember, produces just a positive number. So this is 2 plus 2 is 4. If I plug a 0 in, I get the absolute value of 0 plus 2. 0 plus 2 is 2. And if I plug in a 3, I get the absolute value of 3 plus 2, which is 5. So what I've done is I've gotten y values for each of these x values. And so now I'm going to take the slope for each interval. Okay, so here I'm doing the interval -2 to 0. I'm going to mark there that those are y values. Make sure that you know those are not slopes. Alright, so from -2 to 0. My slope formula says that I'm going to take the y values and subtract them and put them over the x values. So I'm going to do -2 minus 0 in the bottom. That way I don't have a double negative. So the y value at -2 is 4. And the y value at 0 is 2. So that's where I'm getting 4 minus 2 from. So 4 minus 2 is 2. And -2 minus 0 is -2. So the slope here is -1. So now if I do the interval 0 to 3, okay, I'm going to put my 0 and my 3 here in the bottom of my formula. The y value at 0 is 2. My y value at 3 is 5. So my slope here, 2 minus 5 is -3, and 0 minus 3 is -3. So my slope here is a positive 1. So now if I do the interval from -2 to 3, here in the bottom I'm going to put my -2 minus 3 for my x values. My y value at -2 is 4. My y value here at 3 is 5. So my slope, I get 4 minus 5 is -1. -2 minus 3 is -5. So my slope here is 1/5. So because these slopes are all different, this is a nonlinear function. Which I could have told you, by the way, because of the absolute value, right? Those form a V-shaped graph. Alrighty, and that's example number 5. Until next time, guys.